Hi everyone, I'm Dr. Surjit Singh. Last week I had uploaded a video on Leetcode problem for deep copy of a given linked list. Today I'm talking about a refined version of the same problem. Welcome to my video. Let us begin. In this problem, we are given a linked list which has an extra pointer called random pointer. We are to make a deep copy of the list. It means that all nodes will be copied into new memories. Last week, we discussed two solutions of the problem in part 1 of this video, in which we discussed two methods. I will summarize these here. The first method considered a recursive solution to this problem. We traversed the linked list as a graph. We cloned the nodes and saved the relations of the memory addresses of the old and new nodes in a dictionary. First call to the recursive function copyRandList is with head of the node. Call stack grows as shown along with the dictionary. Recursion is called at statement with white mark to fix the next pointers and with orange mark to fix the random pointers. A prime is the final head of the output for which address is obtained from the dictionary. Time complexity is of the order of n and the space complexity is also of the order of n. In the second method, we considered the iterative solution of the problem. Once again, we considered the same dictionary to map the memory addresses of the nodes with the new nodes. Nodes are traversed as a linked list in an iterative manner. In the last iteration, the cloned nodes are linked with each other as shown. Finally, we return the head of the cloned dictionary. Time and space complexities are same in both the methods. For details of these methods, please go through the part 1 of this video. Now we will write the O1 working space version of the iterative solution. For this, we will do away with the dictionary which takes space of the order of n. Consider the same linked list. If the head is none, the resultant list is also none. We will traverse all the nodes thrice. In the first loop, we will create clones of all the nodes. In the first iteration of the first loop, node is the head. We create its clone. Clone next points to node next, and node next points to clone. Finally, node points to clone next. In this iteration, head points to A next points to A prime, and A prime next points to B. In the second iteration, we create the clone of the second node, weave it in between the next pointers, and move the node further in the similar way. In the third iteration, we weave the clone of the third node. In the last iteration, we weave the clone of the fourth node. Note that node next was none at the start of this iteration, so d prime next remains none. Now we start the second loop to fix the random pointers. Node is the head of the first iteration. Node random is not none, so we need to assign value to node next random, that is to A prime random. As node random is C, therefore A prime random must be C prime, which is node random next, for which the link is shown like this. Node next is B, which becomes node for the next iteration. In this iteration, node random is none, so there is no change in pointers and node shifts to C. In the third iteration, we fix the random pointer of third cloned node and node shifts to D. In this iteration, last random pointer is fixed. After this, node becomes none and loop terminates. In the third loop, we unweave the nodes to get two separate linked lists by restoring their next pointers. Node is A, clone is A prime, which is also saved in head clone. Node next is B, which becomes node next. Clone is A prime, its next pointer is not none, it becomes clone next, which is B prime. Both node and clone shift to their next positions. In the next iteration, node next and clone next are fixed as shown. Node and clone shift to next positions. In another iteration, result is as shown. In the last iteration, node next is fixed. However, clone next is none, so this assignment is skipped in the last iteration. Finally, node becomes none and the loop terminates. Head clone is returned as the final result. All the loops run over n, so the time complexity is of the order of 3n, which is same as the order of n. As dictionary is not used this time, the working space memory is constant. The execution is also faster because dictionary maintenance is a slow process. Thank you for your time. Please share my videos with others and stay tuned for more videos on Leetcode problems.